All right, so what we're going to talk about in this lesson is we're going to talk about naming acids. Now, when you guys hear the word acid, you think of all the nice movies you've seen, okay, where people get acid on them and their faces melt off and things like that. Okay, well, yeah, I mean, there are some acids that do that, but that's not what an acid is. Okay? Otherwise, eating an orange would be a really dangerous endeavor because oranges have acid in them. That's why oranges and lemons and things like that have that kind of soury taste, is because of citric acid. It's an acid. All an acid means, okay, the way we're going to define an acid right now for our purposes is that it's a substance that releases hydrogen ions when you dissolve it in water. Okay? Hydrogen ions being H+. That's all we mean. Okay, when you dissolve it in water, it releases H+ ions. So, in order to be an acid, it obviously has to have hydrogen in it, right? So, often when you see the formula of an acid or something like that, hydrogen is going to be the first element in that formula. Now, there's one obvious exception to that. Can you think of it? Formula that starts with H, but it's not an acid. You drink a lot of it, or you should. Water, right? Water, H2O, not an acid. But most other substances that start with H, you're looking at an acid. Because when those things get dissolved into water, it's going to release that hydrogen ion. All right? So, a couple different types of acids. First is called a binary acid. Now, just like other binary compounds, binary acid means there's two elements in it. That's it. All right? Now, one of those elements you know already is, because of the definition of an acid, hydrogen. Right? So it's hydrogen and something else. Okay? Some other element. When you're naming a binary acid, it's always going to follow the same general format. It's going to be hydro, okay? That hydro right there, that's what tells you that it's binary. Okay, hydro something ic acid. That something is that root of the element. Kind of like when you were doing the ide thing, it's that root. Okay, so HCl is hydrochloric acid. HCl is hydrochloric acid. Okay, H2S. This one's a little bit different. Okay, don't get mad at me. I don't make the things, I just teach the things, so don't get mad at me. Slightly, little tweak, okay? Normally you would call that hydrosulfic because sulfur becomes sulfide, so there's a little more. It's hydrosulfuric acid. Sulfur and phosphorus do that for some strange reason. Again, I don't make the stuff, I just teach it. Okay? So, a binary acid is always hydroic acid, whatever that other atom is that is bonded to. Okay? The other type of acid is referred to as an oxyacid. An oxyacid is that hydrogen ion, that H+, with an oxyanion that we have already learned about and you have memorized and all that fun stuff. Okay? So an oxyacid is something like this, H2SO4. Okay? Now, with an oxyacid, there's two choices, because if you think about an oxyanion, they always end with one of two things. They either end with ate or they end with ite, right? You have chlorate, you have chlorite, you have perchlorate, you have hypochlorite. It either ends with ate or ite. The ending of the anion determines the ending of the acid. Okay? So, if the ending of the anion is ate, then what happens is that ending changes to ic. Okay? And note that there is no hydro on it. It's just ic acid. Okay, so H2SO4. SO4 2 minus is a sulfate ion, right? Again, sulfur and phosphorus are a little weird. Sorry, deal with it. Okay, so a sulfate ion becomes sulfuric acid. The ending changes to ic because the ion ends with 8. HNO3 is a nitrate ion, and therefore HNO3 is nitric acid. Okay? Now, if the ending of that oxyanion is ite, then what's going to happen is it's going to be us acid. Okay? Ite changes to us, 8 changes to ic. Okay? So, HNO2, NO2 minus is a nitrite ion, and so we call that nitrous acid. Notice, none of these start with hydro, because remember, hydro is for binary acids. Okay? HClO, ClO minus is a hypochlorite ion, and so the name of that acid, ite changes to us, so it's a hypochlorous acid. Okay? Now, quick and easy, stupid way to remember it is, remember this sentence right here. I ate something icky and got acid-itis. It's silly, it's stupid, and so you can remember it. Okay? So 8 ions become ic acids. 8 ions become us acids. I ate something icky and got acid-itis. Okay? There's no such thing as aciditis. Don't worry, you're not going to get it. Okay? It's just to help you remember. So let's look at some examples. All right? HBr. First question. Is it binary or is it an oxyacid? It's binary because there's only 2 elements, right? So, because it's binary, it's going to be hydroic acid, right? What's the part? Well, it's a bromine atom, so it's brome. So it's hydrobromic acid is the name of that acid. Again, hydro because it's a binary acid. It's not an oxyacid, right? HClO4. HClO4, is that binary or oxyacid? That one's an oxyacid, right? So, ClO4, what's the name of that oxyanion? Well, it's perchlorate, right? So, perchlorate becomes perchloric acid. Okay? Again, you just change the ending. Nothing happens to that prefix. If it's perchlorate, it's perchloric acid. Notice again, there is no hydro because it's an oxyacid. Okay? HiO4, oxyacid, right? And what's the name of IO4? Well, it's periodate, right? Of course, you know all these things, right? Because you memorized them all, right? So, periodate becomes periodic acid. I know it's the same spelling as the word periodic, but it's not called periodic acid because it's always an acid, not periodically. So it's periodic acid. Deal with it. Okay? HF, binary acid, which means hydroic acid. Okay? The is fluorine, so it's hydrofluoric acid. Okay? H3PO4, PO4 is phosphate. And again, phosphorus is that other weird one that does a little extra. Okay? So H3PO4 is phosphoric acid. Okay, again, I didn't do it. H2SO3. SO3, 2 minus, is a sulfite ion, right? So the ending of sulfite becomes OUS, acid-itus, right? So that becomes sulfurous, remember sulfur is weird, acid. Sulfurous acid. Okay? So if it's binary, it's hydroic acid. Okay? If it is an oxyacid that ends in ate, it's just ic acid. If it's an oxyacid that ends in ite, it's us acid. Okay? Now, let's go the other way, because that's what we do, right? So, looking the other way, looking at formulas of acids. Okay, now I've already mentioned this several times. Okay? Drill in and shove this in. Unless you're dealing with a type 3 binary compound, you will look at charges and switch charges. Unless you're dealing with a type 3 binary compound, switch charges to find the formula. This is not a type 3 binary compound. We're going to switch charges. Okay? Well, what charges are we going to switch? Well, remember, an acid is something that generates hydrogen ions in solution. And so, one of your ions is going to be H+, if it's an acid. Okay? So you just got to figure out what the other ion is. Hydrofluoric acid. What does hydro tell you? Okay, has nothing to do with water. Hydro tells you that it's a binary acid. It's hydrogen and one other element. So what other element, I wonder, is this thing bonding with? Well, it's bonding with a fluoride ion, which is F-. So look at your charges, switch your charges, and your formula then becomes HF. That is the formula of hydrofluoric acid. Okay? Phosphorus acid. Notice a couple things. First thing to notice, there is no hydro, which tells you what? Tells you that it's not binary, that it's an oxyacid, right? And then it ends with OUS. What does that tell you? Well, OUS means that the ion ended with ITE, right? So the ion was a phosphite ion, which of course you know is PO3, 3-. Phosphate is PO4, phosphite is PO3. Okay, so you got H+, PO3, 3-. Switch them. You got 3 hydrogens, 1 phosphite, H3PO3. Right? Same as you did with ionic compounds. Nothing's changed. You're just doing it with hydrogen instead of some other cation. Okay? Nitric acid. Again, no hydro, oxyacid. Ic tells you that that ion ends with 8. So nitrate. Nitrate, we got H+, we got NO3-, nitrate. Switch them, and you get HNO3. Okay? Bromic acid, ic, no hydro, oxyacid ending in 8. That is a bromate ion. H+, BrO3-, HBrO3. Hydrosulfuric acid. Okay, we're back to hydro, which again tells you that it's not an oxyacid, right? So you got H+, you got S2-, right? Sulfur has a 2- charge. Switch them, and you get H2S. Okay? It's really not that hard if you think about it and if you look at your charges and switch your charges. All right? So, we're going to work on this. We're going to practice this. Okay? Because that's the only way to do it. You've heard me say that a whole bunch. And at this point, you're probably getting the idea that, yeah, that's true. I need to practice this a lot. right? Practice, practice, practice.